Hello friends, I am Nitish Pradhan. Now I will teach you how to write a program in MULTISIM. Today we will design our first program in MULTISIM. If you are new in MULTISIM platform, if you want to learn MULTISIM platform, then follow my video one by one. So here it is my MULTISIM platform. Okay, in this is I am using MULTISIM 14.1. I am using MULTISIM 14.1. So it is a MULTISIM environment. This is my main programming platform. I will design all kind of circuit and all kind of schematics in this dotted background. After that, in this ribbon, there are present some help, some files, edit, view, and other options. By using this option, will create program one by one. So in this MULTISIM, there in right hand side there is one palette toolbar. In this toolbar, all kind of indicators and measuring components are present. Okay, all those indicators and measuring components are virtual type. Okay, because we cannot design a function generator in MULTISIM platform to give any kind of output. Function generator and oscilloscope are individual independent things. Okay, so now I will teach you how can we connect, how can we write. So our first program is to check function generator. Okay, we will try to connect function generator with oscilloscope. So right now, okay, come here in right hand side. This one is function generator. Take one function generator, place in the MULTISIM. Again, come to the palette and take one oscilloscope. Place this oscilloscope in MULTISIM. Okay, and zoom it slightly. Now press Ctrl W. Whenever you will place Ctrl W, it will open a database. Whenever you press Ctrl W, it will open select a component function. Select a component window. In this select a component window, there is one master database. Okay, and in this master database there are various kind of groups. So we'll select first group, that is a source. In this source, come to the ground source. First select source from all database. Follow my process, master database. Okay, in the all groups, source in power supply and ground. Take one ground and take another ground. Connect one ground with this common port. Okay, common port. Cut this one and connect ground with this negative terminal. Okay, common port and negative terminal. Now right click here and connect this port. Okay, and make a connection. Now double click on the function generator. It will open a function generator controller. It is a function generator palette. Okay, by using this function generator, we can control the function generator, and to show the output, double clicking the oscilloscope, it will open the oscilloscope view. Now this is our run button. Now I am clicking my run button, and this oscilloscope is displaying one sine waveform. Why it is a sine waveform? How I know it is a sine waveform? Okay, look at here in function generator. I have selected here sine. Okay, this signal is a sine waveform, but it is just showing like ramp. Why? Because my frequency is 1 Hz. Just because it's showing this kind of ramp signal. Now change my frequency. I will give the value 10. Okay, now if I will give value 10, then it will show one complete sine waveform. If I will change the frequency 100, then it will give 10 sine waveform in this window. Okay, so we can change our frequency by this platform like this. Okay, here hertz, millihertz, microhertz, nanohertz, picohertz or femtohertz, and here mega, giga, beta, tera. Okay, so now we can change the amplitude from this platform also. We can change the amplitude from 5, 51, 20, any kind of amplitude we can give this platform. It is picovolt to change volt. Okay, now I am keeping my I am giving the amplitude 10 and try to check what kind of output it displaying this waveform. Okay, 10 volt. So look at here in oscilloscope. Look here in oscilloscope. Here there is the x-axis. This one is x-axis. This one is y-axis. X-axis is the timing axis. Timing axis. X-axis is timing axis, and y-axis is, and the y-axis is our amplitude axis. Okay, this x-axis and y-axis, one is the timing axis and another one is my amplitude axis. This, so here it's showing 10 millisecond per division. This one block is the one division, and this one division block is giving 10 milliseconds. For the y-axis, this one is the y-axis, this is 5 volts per division. This one is 5 volts. I am giving here 10 volts, 10 volts peak. Just because 5 volt and 5 volt is making 10 volts. 5 volt and 5 volts is making 10 volts. And here, this one is a 10 millisecond and 10 millisecond glass. 10 millisecond and 10 millisecond glass. Okay. Now, you can change here. Okay. You can change here waveform types. This is my triangular waveform and this is my square waveform. Now, this square waveform is not looking completely square. Why? Okay, I will tell you after some experiments. Okay, this is my square waveform. Okay, it is my square waveform. It is my triangular waveform. Now, if I will give the 5 volts, then what? I am giving the 5 volts. Okay, so it's just because this one division is 5 volts, so showing this one division. Okay, if I will give 4 volts, then what? It look like 4 volts. Okay, you can change 6 volts, so it will generate a 6 volt. Now I am going to stop this program and let's do something different. Okay, this one is the positive function generator channel, this is negative function generator channel. This one generates same waveform with the negative value. Now connect this with a signal like this. Right click on this wire, come to the color segment, select this one and press OK button. Okay, after that delete this signal, ground option, we connect both the ground option with same, and now double click and open. Now you can see there are two signals. One signal is blue and one signal is red. The positive generated signal is red and negative generated signal is blue. Positive generated signal is red and negative generated signal is blue. Okay, positive generated signal is red. Now if I will change, okay, look at here, we can see here the waveform, the square waveform is completely squared. Okay, square waveform is completely squared to make good visibility. And now you can see the square waveform is completely squared, not like the previous one. Why? Because here I am using the common ground concept. Just because it's giving us the complete square waveform. So by using this kind of connection, you can check your circuit. So thank you for watching this video. Okay, and if you like, then follow, and thank you.